Imagine for a moment that the most abundant element in the entire universe, the very first atom that emerged after the Big Bang, the fundamental building block of stars and galaxies, is sitting right there in your kitchen, in the water you drink, in the food you eat, and even in your own body. This element is so simple, so incredibly basic, that it consists of just one proton and one electron. Yet it holds the power to revolutionize our entire energy system, to take humanity to distant planets, and potentially to save our civilization from climate catastrophe. I'm talking about hydrogen, and today you're going to discover why this invisible, odorless, and incredibly light gas might be the most important substance for your future and the future of every living being on this planet. Before we dive deep into this fascinating journey, I want you to do something for me. Think about the last time you filled up your car with gasoline, or when you paid your electricity bill, or even when you looked up at the night sky wondering what powers those countless stars. Keep that thought in your mind, because by the end of this video, you'll understand how hydrogen connects all these things in ways you never imagined. And if you're already curious about how this tiny atom can change everything we know about energy and technology, drop a comment right now telling me what you already know about hydrogen. I read every single comment, and your engagement helps this content reach more people who are curious about science just like you. Let's start our story in 1766, in a laboratory in London, where a brilliant scientist named Henry Cavendish was conducting experiments with metals and acids. When he mixed iron with sulfuric acid, he noticed something extraordinary. A strange gas was being released, a gas so light that it would rise immediately into the air. Cavendish called it inflammable air, because when he ignited it, it produced a spectacular flame. But the truly revolutionary discovery came when he realized that when this gas burned in the presence of oxygen, it produced water. Yes, water. This was mind-blowing for the scientific community of that era, because it proved that water, which everyone thought was a basic element, was actually composed of two different gases combined together. A few years later, the French chemist Antoine Lavoisier gave this element its proper name, hydrogen, which comes from Greek words meaning water former. And isn't that poetic? The element that makes up most of the universe has a name that literally means it creates water, the essence of life itself. Now, you might be wondering, if hydrogen was discovered over 250 years ago, why are we suddenly talking about it so much now? Why is everyone from tech billionaires to government leaders investing billions of dollars into hydrogen technology? The answer lies in a problem that affects every single person watching this video right now: our desperate need for clean energy. Every time you charge your phone, drive your car, heat your home, or even watch this video, you're consuming energy. And most of that energy, even today, comes from burning fossil fuels like coal, oil, and natural gas. These fossil fuels release carbon dioxide and other greenhouse gases into our atmosphere, trapping heat and causing global temperatures to rise at an alarming rate. We're seeing the consequences everywhere: more intense hurricanes, devastating wildfires, melting ice caps, rising sea levels, and ecosystems collapsing. Scientists have been warning us for decades that we need to transition away from fossil fuels. But here's the challenge. We need energy sources that are not just clean, but also powerful, reliable, and practical for all the different ways we use energy in modern life. This is where hydrogen enters the stage as a potential superhero. When you burn hydrogen or use it in a fuel cell to generate electricity, the only byproduct is water vapor. That's it. No carbon dioxide, no toxic fumes, no greenhouse gases, just pure water. It's like having your energy cake and eating it too. But hydrogen isn't just clean, it's also incredibly energy dense. Kilogram for kilogram, hydrogen contains about 3 times more energy than gasoline. Let that sink in for a moment. 3 times more energy. This means that if we could efficiently use hydrogen, we'd need much less fuel to power our vehicles, our industries, and our lives. And here's something that will blow your mind. Almost all the hydrogen in the universe was created in the first few minutes after the Big Bang, about 13.8 billion years ago. The hydrogen atoms that could power your future car are literally as old as the universe itself. If that doesn't make you see energy in a completely different light, I don't know what will. But let's get practical and talk about how hydrogen is actually being used today, because it's not just some futuristic fantasy. Hydrogen is already a massive industry, with millions of tons produced every year for various applications. One of the biggest uses of hydrogen is in fertilizer production. You see, modern agriculture depends heavily on synthetic fertilizers, and the most important fertilizer is ammonia, which is made by combining hydrogen with nitrogen from the air. This process, called the Haber-Bosch process, was invented in the early 1900s, and it literally transformed global food production. Before this invention, we simply couldn't grow enough food to feed the world's growing population. Today, it's estimated that about half of the nitrogen in your body comes from synthetic fertilizers made with hydrogen. So every time you eat bread, vegetables, or any food grown with modern farming methods, you're benefiting from hydrogen technology. It's not an exaggeration to say that hydrogen helps feed billions of people every single day. Hydrogen also plays a crucial role in the petroleum refining industry. When crude oil comes out of the ground, it's a complex mixture of different hydrocarbons, many of which aren't suitable for use as fuel. Refineries use hydrogen in a process called hydrocracking to break down these heavy hydrocarbons into lighter ones like gasoline, diesel, and jet fuel. Hydrogen is also used to remove sulfur from petroleum products, making them burn cleaner and produce fewer pollutants. So ironically, even though we're trying to move away from fossil fuels, hydrogen is currently essential for producing the very fossil fuels we use every day. And speaking of irony, most of the hydrogen produced today is actually made from natural gas through a process called steam methane reforming, which does release carbon dioxide. So we're in this interesting transition period where we're using fossil fuels to make hydrogen that we want to eventually use to replace fossil fuels. It's like building a ladder to climb out of a hole using materials from the hole itself. Now, let me ask you something. And I really want you to think about this and share your thoughts in the comments. If you could power your home entirely with clean hydrogen, knowing that the only emission would be water vapor, would you do it? What concerns or questions would you have? Drop your answer in the comments because this is exactly the kind of conversation we need to be having as a society right now. And if you're finding this information valuable, hit that like button to help more people discover the incredible story of hydrogen. The applications of hydrogen extend far beyond fertilizers and refineries. In the world of chemistry and materials science, hydrogen is absolutely essential. It's used in the production of countless chemicals, from plastics to pharmaceuticals. Hydrogen is used to create methanol, which is a key ingredient in producing formaldehyde, acetic acid, and many other industrial chemicals that end up in products you use every day. In the electronics industry, hydrogen is used in semiconductor manufacturing, helping to create the computer chips that power your smartphone, your laptop, and virtually every electronic device in your home. The flat screen television you might be watching this on right now was likely manufactured using processes that involved hydrogen. It's fascinating how this simple element is hiding in plain sight, embedded in the manufacturing history of almost everything around you. But let's talk about what really gets people excited about hydrogen: transportation. The idea of hydrogen-powered vehicles has been around for decades, but it's only in recent years that the technology has become practical and commercially available. Hydrogen fuel cell vehicles work in an elegant way. Hydrogen gas is stored in high-pressure tanks in the vehicle. This hydrogen is then fed into a fuel cell, where it reacts with oxygen from the air. This reaction produces electricity, which powers an electric motor to drive the car, and the only thing that comes out of the tailpipe is water vapor. You could literally collect the exhaust from a hydrogen car and drink it, although I don't recommend it because it wouldn't taste very good. Major car manufacturers like Toyota, Honda, and Hyundai have already released hydrogen fuel cell vehicles. The Toyota Mirai, for example, can travel over 300 miles on a single tank of hydrogen and can be refueled in just about 5 minutes, just like a conventional gasoline car. Compare that to battery electric vehicles, which can take anywhere from 30 minutes to several hours to fully recharge, depending on the charging station and battery size. Now, I know what some of you are thinking. If hydrogen cars are so great, why don't we see them everywhere? Why are battery electric vehicles like Tesla's so much more common? The answer comes down to infrastructure and economics. Building a network of hydrogen refueling stations is expensive and complex. Hydrogen needs to be stored at very high pressures, around 700 times atmospheric pressure, or at extremely cold temperatures if you want to store it as a liquid, which is about -250, 3 degrees Celsius. That's just 20 degrees above absolute zero. These extreme conditions require specialized equipment and safety measures. In contrast, electricity is already distributed everywhere through the power grid, so installing charging stations for electric vehicles is relatively straightforward. There's also the efficiency question. When you use renewable electricity to produce hydrogen through electrolysis, then compress or liquefy that hydrogen, transport it to a refueling station, and finally convert it back to electricity in a fuel cell to power a car, you lose a significant amount of energy at each step. Battery electric vehicles, which use electricity directly from the grid to charge batteries, are much more efficient overall. So for passenger cars, batteries currently have the advantage. But here's where it gets really interesting, and this is something that doesn't get talked about enough. Hydrogen might not be the best solution for your daily commute, but it could be absolutely essential for other forms of transportation. Think about long-haul trucks driving thousands of miles across the country, carrying heavy loads. Batteries for those trucks would be enormous and incredibly heavy, reducing the cargo capacity and requiring very long charging times. Hydrogen fuel cells could provide the range and quick refueling that the trucking industry needs. Several companies are already developing hydrogen-powered semi-trucks for exactly this reason. Then consider ships and airplanes. Large cargo ships currently burn some of the dirtiest fuel on the planet, called bunker fuel, and they're responsible for a significant portion of global greenhouse gas emissions. Batteries are far too heavy for large ships and planes, but hydrogen, especially in liquid form, could work. Aviation companies are seriously researching hydrogen-powered aircraft, and while it will take years to develop and certify these planes, the potential is enormous. Imagine flying across the ocean on a plane that emits nothing but water vapor. That's not science fiction. That's a real possibility within your lifetime. What do you think is the most promising application for hydrogen? Transportation, power generation, or something else entirely? Let me know in the comments, and don't forget to subscribe if you want to keep exploring cutting-edge science and technology with me. Your subscription genuinely makes a difference in helping this channel grow and reach more curious minds like yours. Let's talk about something that might surprise you. Hydrogen in space exploration. This is where hydrogen really shows its power, quite literally. Liquid hydrogen has been used as rocket fuel since the early days of space exploration. When liquid hydrogen combines with liquid oxygen in a rocket engine, it produces an incredible amount of thrust and the highest specific impulse of any chemical rocket propellant combination. Specific impulse is essentially a measure of how efficiently a rocket uses its propellant, and hydrogen-oxygen rockets are the champions. The Space Shuttle's main engines ran on liquid hydrogen and liquid oxygen. The massive orange external tank you saw in pictures of the Space Shuttle was filled with these super cold liquids. Today's most powerful rocket, the Space Launch System that NASA is using for missions to the Moon and eventually Mars, also uses liquid hydrogen. When we send humans to Mars, which several space agencies and private companies are planning to do in the coming decades, hydrogen will likely play a central role, not just in getting us there, but also in sustaining us once we arrive. Here's a mind-bending idea. We could potentially use hydrogen as both fuel and life support on Mars. The Martian atmosphere is mostly carbon dioxide, and through a process called the Sabatier reaction, we can combine carbon dioxide with hydrogen to produce methane and water. The methane could be used as rocket fuel for the return journey to Earth, and the water could be split into hydrogen and oxygen through electrolysis. The oxygen would be used for breathing, and the hydrogen would be recycled back into the Sabatier reactor. It's a beautiful closed-loop system that could make long-term Mars missions feasible. Scientists call this in situ resource utilization, which is a fancy way of saying we use what's already there rather than bringing everything from Earth. And if we can find water ice on Mars, which we're pretty sure exists in significant quantities under the surface and at the poles, we could extract hydrogen directly from Martian water. This means hydrogen isn't just fuel for getting to other planets. It's potentially the key to establishing permanent human settlements beyond Earth. Now let's dive into one of the most exciting and controversial aspects of hydrogen: the different colors of hydrogen. No, hydrogen gas itself doesn't change color, but scientists and policymakers use a color coding system to describe how hydrogen is produced, and this matters enormously for the environment. Gray hydrogen is made from natural gas through steam methane reforming, which releases carbon dioxide into the atmosphere. This is currently how most hydrogen is produced, and it's responsible for significant carbon emissions, roughly equivalent to the annual emissions of the United Kingdom and Indonesia combined. Not great for fighting climate change. Blue hydrogen is also made from natural gas, but the carbon dioxide produced in the process is captured and stored underground, using carbon capture and storage technology. This is better than gray hydrogen, but carbon capture isn't perfect, and there are questions about the long-term security of storing carbon dioxide underground. Then we have green hydrogen, which is the holy grail. Green hydrogen is produced by using renewable electricity, like solar or wind power, to split water into hydrogen and oxygen through electrolysis. This process produces zero carbon emissions if the electricity comes from renewable sources. Green hydrogen could be the ultimate clean fuel, but right now it's much more expensive than gray or blue hydrogen. There's also turquoise hydrogen produced by methane pyrolysis, which splits natural gas into hydrogen and solid carbon instead of carbon dioxide. Pink hydrogen produced using nuclear power, and even yellow hydrogen produced using mixed renewable and non-renewable electricity. The rainbow of hydrogen colors reflects the complexity of our energy transition. We can't simply flip a switch and move from fossil fuels to clean energy overnight. We need bridge technologies and economic incentives, and we need to build massive amounts of new infrastructure. Governments around the world are investing billions in hydrogen strategies. The European Union has committed to becoming a leader in green hydrogen, with ambitious goals to install gigawatts of electrolyzer capacity by 2030. Japan is building a hydrogen society with plans for widespread adoption of fuel cells in homes and vehicles. China is investing heavily in hydrogen technology and infrastructure. The United States passed major legislation supporting clean hydrogen development. This is happening right now, and the decisions being made today will shape the energy landscape for generations. But I want to talk about something that doesn't get enough attention: the challenges and potential dangers of hydrogen. This isn't meant to scare you, but rather to give you a complete picture. Hydrogen is the smallest molecule in existence, which means it can leak through materials that would contain other gases. Hydrogen embrittlement is a phenomenon where hydrogen atoms infiltrate the crystal structure of metals, making them brittle and prone to cracking. This is a serious concern for pipelines and storage tanks. There's also the obvious fact that hydrogen is highly flammable. You've probably heard about the Hindenburg disaster in 1937, when a hydrogen-filled airship caught fire and was destroyed in just 34 seconds, killing 36 people. That disaster effectively ended the era of passenger airships and gave hydrogen a dangerous reputation that persists to this day. However, it's worth noting that hydrogen is not inherently more dangerous than gasoline or natural gas. It's just dangerous in different ways. Hydrogen flames are nearly invisible in daylight, making them hard to detect. But hydrogen is also much lighter than air, so if it leaks, it dissipates quickly upward, rather than pooling on the ground like gasoline vapors. Modern hydrogen systems include multiple safety features, like leak detectors, automatic shutoff valves, and careful ventilation design. Here's a question I want you to really think about and share your perspective on in the comments. Knowing that every energy source has risks and benefits, from the carbon emissions of fossil fuels to the battery materials, mining for electric vehicles to the safety challenges of hydrogen, what factors do you think should matter most when we decide our energy future? I'm genuinely curious about your thoughts, so please take a moment to comment. And if you're still watching, thank you for sticking with me through this deep dive. If you found this valuable, smash that like button and make sure you're subscribed with notifications on, so you don't miss future videos where we explore more fascinating science topics. Let's talk about hydrogen storage, because this is one of the most challenging and ingenious aspects of hydrogen technology. Storing hydrogen efficiently is tricky because it has such a low density. At room temperature and atmospheric pressure, hydrogen gas takes up a lot of space for relatively little mass. The most common method is to compress hydrogen to very high pressures, typically 350 or 700 bar. That's 700 times the pressure of the atmosphere at sea level. This requires strong, lightweight tanks made from carbon fiber and other advanced materials. These tanks are incredibly tough and have been tested extensively for safety, but they're also expensive to manufacture. Another approach is to liquefy hydrogen by cooling it to -250, 3 degrees Celsius. Liquid hydrogen is much denser than compressed gas, but keeping it that cold requires significant energy and specialized insulated containers. Even with excellent insulation, some liquid hydrogen will always boil off over time, which is called boil-off loss. Scientists are working on alternative storage methods that could be game changers. Metal hydrides are materials that can absorb hydrogen atoms into their crystal structure, kind of like a sponge absorbing water. When you want to release the hydrogen, you simply heat up the metal hydride. This could potentially provide a safer and more compact way to store hydrogen, though the materials are often heavy and expensive. Chemical hydrogen carriers are another fascinating approach. Ammonia, which is made from hydrogen and nitrogen, is much easier to store and transport than pure hydrogen. You can then extract the hydrogen from ammonia when you need it. Several companies are exploring using ammonia as a hydrogen carrier for international shipping, because you can transport ammonia in regular tankers similar to those used for liquefied natural gas. There's even research into organic compounds that can absorb and release hydrogen reversibly, creating a kind of liquid that carries hydrogen without needing extreme pressures or temperatures. Each of these approaches has trade-offs between cost, efficiency, weight, and practicality. And it's likely that different storage methods will be used for different applications. Now let's explore something truly revolutionary that's happening right now: power to gas and the hydrogen economy. One of the biggest challenges with renewable energy like solar and wind is that they're intermittent. The sun doesn't always shine, and the wind doesn't always blow, but we need electricity 24 hours a day. Batteries can store some excess electricity for short-term use, but what about long-term storage, like saving summer solar energy to use in winter? This is where hydrogen comes in. When you have excess renewable electricity that would otherwise be wasted, you can use it to produce green hydrogen through electrolysis. That hydrogen can be stored for weeks, months, or even longer. Then, when you need electricity and the renewables aren't producing, you can use the hydrogen in fuel cells or gas turbines to generate electricity again. You can also inject hydrogen into natural gas pipelines, blending it with the natural gas we already use for heating and cooking. Many countries are experimenting with blending up to 20% hydrogen into existing natural gas networks. Eventually, as we transition away from fossil fuels entirely, these pipelines could carry pure hydrogen. This would allow us to decarbonize heating, which is currently one of the hardest sectors to clean up. Industrial applications are another huge opportunity for hydrogen. Industries like steelmaking, cement production, and chemical manufacturing are responsible for massive carbon emissions, and many of these processes require such high temperatures or specific chemical reactions that they're extremely difficult to electrify. But hydrogen could replace coal and natural gas in many industrial processes. Several companies are developing hydrogen-based steel production, where hydrogen is used instead of coal to remove oxygen from iron ore. This could eliminate roughly 7% of global carbon emissions that currently come from steel production. That's enormous. Imagine if every skyscraper, bridge, and car in the future is made from steel produced with clean hydrogen. The building blocks of our civilization could become carbon neutral. The cement industry is also looking at hydrogen as a way to reduce emissions. These industrial applications might not be as visible or exciting as hydrogen cars or rockets, but they're absolutely critical for achieving global climate goals. There's also a growing interest in using hydrogen for distributed power generation. Fuel cells can be installed in buildings to provide combined heat and power. The fuel cell generates electricity, and the waste heat from the reaction is used to heat water or space heating. This is much more efficient than getting electricity from a central power plant and heating your home separately with a furnace or boiler. In Japan, hundreds of thousands of homes already have residential fuel cell systems called farm. These systems use natural gas to produce hydrogen on site, which then generates electricity and heat for the home. While this isn't as clean as using green hydrogen, it's more efficient than conventional systems and represents a stepping stone toward a hydrogen-based energy system. Imagine every home becoming its own mini power plant, generating electricity and heat quietly and cleanly with no combustion, just electrochemical reactions producing water. Before we wrap up, I want to share something that really puts hydrogen into perspective. Every single atom of hydrogen in the universe, except for trace amounts created in certain nuclear reactions, was formed in the first few minutes after the Big Bang. For about 13.8 billion years, these hydrogen atoms have been floating through space, fusing together in the cores of stars to create all the heavier elements, including the carbon in your body, the oxygen you breathe, and the iron in your blood. Stars are essentially giant hydrogen fusion reactors, converting hydrogen into helium and releasing enormous amounts of energy in the process. This is the same nuclear fusion process that scientists are trying to recreate here on Earth in fusion reactors, which could one day provide virtually unlimited clean energy. And here's the beautiful circle. If we succeed in creating practical fusion power plants, we'll be using hydrogen, the first element of the universe, to generate clean energy by mimicking the processes that power the stars. In a very real sense, hydrogen connects us to the cosmos and to the fundamental forces that have shaped the universe since the beginning of time. So where does this leave us? Hydrogen is not a perfect solution to all our energy problems. It's not going to replace batteries in your smartphone or laptop anytime soon. It has challenges with production costs, infrastructure, storage, and safety that need to be addressed. But hydrogen is also an extraordinarily versatile element with unique properties that make it invaluable for certain applications. From feeding billions of people through fertilizer production, to powering our journey to other planets, to potentially providing clean energy for heavy industry and long-distance transportation, hydrogen is already essential to modern civilization and will likely become even more important in the future. The question isn't whether we'll use hydrogen, but rather how we'll produce it, how we'll use it, and how quickly we can transition from gray hydrogen to green hydrogen. The hydrogen economy isn't some distant dream. It's being built right now, with pilot projects, commercial applications, and massive investments happening around the world. Your life will be touched by hydrogen technology in ways you probably don't even realize yet. The fertilizer that helped grow your food, the refined petroleum in vehicles you see on the road, the electronics manufacturing processes for your devices, and increasingly, the clean energy systems that will power your future. And if you're part of the younger generation watching this, you'll likely see hydrogen go from a niche industrial chemical to a mainstream energy carrier during your lifetime. You might drive a hydrogen-powered truck, fly in a hydrogen airplane, heat your home with hydrogen, or work in an industry that uses hydrogen instead of fossil fuels. I hope this journey through the world of hydrogen has opened your eyes to the incredible story of this simple yet powerful element. If you learned something new today, if this changed how you think about energy in the future, or if you have questions or thoughts you want to share, please leave a comment below. What aspect of hydrogen technology excites you most? What concerns do you have? What questions are you still wondering about? I read every comment, and your engagement truly helps this content reach more people. And if you found value in this video, the best way to support this channel and help me create more in-depth science content is to hit that like button and subscribe. Make sure notifications are turned on so you never miss a video when we explore the cutting edge of science and technology. Thank you so much for watching, for thinking critically about these important topics, and for being curious about the world around you. That curiosity, that desire to understand how things work and how we can build a better future, that's what drives scientific progress. Keep asking questions, keep learning, and I'll see you in the next video where we'll continue exploring the fascinating world of science together.